SysML v2. Lesson 1. The Syntax Shock. If you are coming from SysML v1, opening a SysML v2 file for the first time feels like walking into the wrong room. Where are the boxes? Where are the lines? Why am I looking at code? Welcome to the textual notation. Before you panic, let's look at why this is a massive leap forward for engineering precision and why it does not mean the death of diagrams. In SysML v1, our models were graphical first. Under the hood, they were serialized into XMI, a format designed for machines, not humans. SysML v2 changes the game by introducing a standardized textual syntax that is human-readable. You can read the model definition without a specialized tool. Complete. The text fully encapsulates the model's semantics, meaning you can exchange models between tools with much higher fidelity than XMI allowed. Diff-able. Because it is text, you can finally use standard DevOps tools, like Git, to see exactly what changed between version A and version B. Definition versus usage. In v1, we lived in a world of blocks. In v2, we shift to a usage-focused paradigm. Look at the snippet in the image. Part def vehicle is the definition. It describes what a vehicle is, similar to a block in v1. Part my car vehicle is the usage. It describes a specific occurrence of that vehicle in a larger system context. This separation allows for deeply nested hierarchies without the block explosion often seen in v1 project trees. Do we lose the diagrams? No. This is the biggest misconception. SysML v2 provides complementary textual and graphical representations. You don't have to choose. You get both. The power of tools. While the language spec defines the notation, modern tools like SysModeler leverage this text to auto-generate diagrams like PlantUML views in real time. The workflow. You might script a complex architecture in text to save time, then switch to a graphical view to present it to stakeholders. Under the hood. CurML. SysML v2 isn't just a profile of UML anymore. It is built on a new semantic foundation called the Kernel Modeling Language, or CurML. This provides a formal logical foundation, making your requirements and constraints mathematically rigorous rather than just annotated boxes. Here is a v1 versus v2 cheat sheet. Pause the video to take a closer look. Next lesson, we dive into the engine room to understand CurML and the layered architecture of the language.